Well, hello Internet, and welcome to my new C++ tutorial. In this tutorial, I'm going to teach you C++ through problem solving, and I will cover everything for both Mac OS as well as Windows, and I'm going to be using NetBeans, and if you don't have that installed, in the description I have a link to how to set that up on both Windows and Mac OS. Also in the description I have a full transcript as well as a cheat sheet for the entire tutorial, and I have a lot to do, so let's get into it. Okay, so here we see NetBeans on Mac OS, and here we see it on Windows. See? Exactly the same exact thing. Okay, so what I'm going to do here first is I'm going to create a new project on both, and you'll be able to see how that's set up. So we're just going to go File and New Project, and this is the Mac OS version. And what we're going to do is come over here to C++ Application and click on Next, and then CPP Application. This is going to be wherever you want this to be located. I'm going to call this CPP Tutorial, and I'm going to leave everything exactly the same and click on Finish. After you do that, you're going to be able to go over here, Source Files, and click on Main CPP, and that is going to open up for you, as you can see right there. Alrighty, and I have my output window over here. Yours is probably going to be down here in the bottom. All you do is you just drag it wherever you want it to go, and that is going to define where your output window goes. Okay, so I'm going to leave mine on the right. Also, you may be asking yourself, why is this dark? Yours is probably white. What you're going to want to do is go to Tools if you want this, and then go to Plugins. If you're going to want that, you're going to see I already have it installed right here. See, it says Darkula, LAF, NetBeans. Well, if you want it, what you're going to have to do is go to Available Plugins and then type in DAR, Darkula, TARC, and it will pop up. I already have it installed, so it doesn't show up there. But if you don't care about it being dark, don't worry about it. And if you have any problems with that, don't worry about it either. And to create a new project in Windows, you're going to do the same thing. You're going to go up here, you're going to go File and New Project. This is going to pop up. I'm going to go and choose CPP, this guy right here, C++ Application. Click on Next. And then I'm going to call this CPP Tutorial. Once again, click on Browse to define where I want to save it. And I'm going to go in my C directory, and then I'm going to go into Users, and then pick my name. And then in my Documents directory, you can see I have C++ Tutorial. I'm going to put it there. Okay, so C++ Tutorial, and I'm going to say Open, and that's where everything's going to be stored, and I'm going to click on Finish. And then once again, over in your source files, you can just double click on main.cpp, and you're going to see there are all of your code. Okay, so here we are once again. I'm going to go and get rid of this. You can see right here is an example how to create multi-line comments. So you're just going to put a / and a star, and then to close it, you're going to have a star and a /. I'm just going to get rid of all this stuff. I'm going to be bouncing back and forth between the Mac OS version and the Windows version here, just so I cover everything. Now, the very first line we have here is include and C standard library. What these are called are preprocessor directives, and what they're going to do is load files and objects which contain pre-made functions and objects for your use. And this guy right here, specifically, the C standard library, is going to contain functions for converting from one data type to another, random number generators, memory management, searching, math, sorting, and a whole bunch of other general purpose functions. We're going to go and also include another one. And if you don't catch what I say, don't worry about it, because I'm going to cover things multiple times over and over again. I'm not a big guy in memorizing. I believe that you will naturally just remember what you need to remember through use. This guy right here is going to provide a whole bunch of functions for performing input and output operations. Let's go and throw a couple more inside of here just to get them all the ones that we're going to need. We're going to get string also, and these are called preprocessor directives. And we're also going to get vector, and what vectors are going to do, they are going to be resizable arrays. And if you don't know what array is, I'm going to cover that in this tutorial. And also I'm going to use stream, and what this is going to allow us to do is to manipulate strings, which are just a series of characters. Then we get to this guy right here, this namespace. By using this, you are going to, well, if we want to output information on our screen, we are going to either have it be like this, and hello world, for example. Okay, so that is a way for us to output information on the screen. If you have this guy here, that is going to allow you to eliminate the use of typing in std. By using this, however, you may have conflicts if you define functions that share a name in the standard namespace. So in this tutorial series, I am not going to use it. So I'm going to get rid of it altogether. So we're just going to have to type out this part right here and a little bit more typing, but it will get rid of a couple potential problems later on. Now you could also come in here, and if you just wanted to use this for outputting information to the screen, and that's what this does, it outputs information to your terminal or over here in your little output box. You could also come in and just type in using standard cout like that, and then you would only have to type in cout also. But I'm going to get rid of that also. Alrighty. That brings us down to this line. Now, execution of all of your code is going to start with your main function, and argc and argv are going to be optional data that is going to be passed to your program if it should be executed on the terminal. And if you decide to use it, this guy right here is going to store the number of arguments passed to your computer, to your program whenever you run it. And this is going to be an array that is going to point to a whole bunch of values or strings in this situation that are passed to your program whenever it's executed from the terminal. And I'm going to show you what that works like, or how that works here in a second. And I'm also going to show you how everything works exactly on Windows as well, just so you are 100% positive that everything's going to work the same. Now I put this guy right here as a new line. Another option that you have available to you is you could also do a new line with std like that and endl. And that is also going to give you a new line, or provide you with a new line option. Okay? And we could actually come in here and check that this works. We could come in and execute it just by clicking on this little guy up here. And whenever I do that, you're going to see hello world pops up right there. And I went and enlarged the right side, our output window here, just so you will be able to see it. And if you want to know how to do that, you just right click and then come here where it says larger font. And also if you would want to enlarge your text inside of this is on Mac OS. What you're going to do is go NetBeans and preferences and fonts and colors. And here you're going to be able to change your font and color just by clicking on that, picking what you want. And also on Windows, you're going to do pretty much the same exact thing, except you're going to go to Tools, and you're going to go to Options, and you can see Fonts and Colors, and then you click on this guy right here and change your font and color. All right, so good stuff. Oh, and this is how you move your output window. So I just grabbed it, and I'm going to drag it over here like that. And now you can see the output window on the right side of your screen. And just like before, you're going to be able to come over here and right click inside of your window and go larger font to increase the font to whatever size you want it to be. Okay, so just to be technical, what's going on here right here is this guy right here, cout, is going to represent your console or your screen. This guy right here is called the stream insertion operator, and what it's doing is it's taking this string and also this new line, and it is sending it to your screen. Okay, pretty simple stuff. It just looks crazy and foreign, but that's all it's doing. It's saying, hey, I want the screen to receive this string and this new line, and I want to put it on the screen. Okay, simple stuff. Now what I want to do is show you how to make these guys work, even though you're not really going to use them very often. But I just want to, cover everything. So what we're going to do first is we are going to check if any arguments were passed. Now, if no arguments are passed, what you're going to get as a value for GR or ARGC is actually going to be 1. So we're going to say if it's not equal to 1, that means we received something and we're going to be able to process it. Then what I'm going to do is I'm going to print out what they actually sent with our program. So I'm going to go cout, and I'm going to say something like you entered, and then I'm going to say what they entered, and that's argc arguments. And you can go to the new line like that. That's not going to cause any problems. So I'm going to go arguments, and that's going to print out the number of arguments that they passed. And I'm just going to throw a new line in there instead of endl like we normally did. Then what I'm going to do is I'm going to cycle through every single thing that is in this guy right here, which is an array. Now, to do that, an array is just a box of values. That's all it is. And each of those values is going to be stored sequentially in memory. And each of those values is going to be at a specific address. Just like your house has addresses, arrays have addresses. However, we are going to refer to addresses, at least in this situation with arrays, by the name of index. And the index starts at 0 and then goes to 1, 2, 3, 4, and upwards and forever. Now, if we want to cycle through those values, we just need a way to increment the index so that we will be able to print out every single array. One way to do that is with a for loop. and you may or may not be aware of how for loops work. And this tutorial series is going to get progressively more complicated. It's going to get complicated quickly. So if you're thinking this is kind of boring and I know all this stuff, don't worry, we're going to get to it. So what I need to do is first start off with index 0. That's what I'm doing right here. And int just means this is an integer. That means there's no decimals involved. And what we're going to do is we're going to continue incrementing the indexes as long as I is less than the number of items that were passed into it. So we're going to cycle through all those. And then what we want to do, this is a shortcut that says that we want to increment the value of I. So we're going to go from 0 to 1, and it's going to be 0 as we execute the code, and then it's going to come back up here, and then it's going to increment to 1 thereafter. So what we need to do is access the information that is stored in the indexes of our array. So we go argv, this guy right here. And if we want to access a specific index, we just go and put the I inside of there, and then I'm going to throw a new line after that. And there we go. And that's going to provide us basically to cycle through all of those different items. And then this guy down here where it says return 0, what that is saying is whenever we return a value of 0, that means that our program executed properly. If we would return a -1, that would mean that some type of an error occurred. So that is every single thing, the meaning of every single thing you see on your screen. So we're going to save that. And we're going to copy it. And just to show you that everything's the same, I'm going to come over here and I'm going to select all. And I'm going to paste in everything that we have over there. And we're going to run it because this is about the only thing that's going to be different between Mac OS and Windows. Now on Mac OS, I'm going to run this in the terminal. And I could actually run the terminal inside of NetBeans, but I'm going to do it in a different way. So I'm going to go Command and space. I'm going to type in terminal like that. And hit enter, and then this guy's going to open up. I can go ls to see what I have. You might have to change your directory to wherever you want to go, but I'm actually in the directory where I want to be. And if I want to come in here and execute my program and pass in a series of values, I can do that inside of here. What I'm going to do is I'm going to go g++ and main.cpp, and there that is, and that went and compiled it. And now to execute my code, I'm going to go ./a.out. I'm going to say I love C++. And it didn't work, and the reason why is probably because I'm in the wrong directory. So let's go back a different directory. Do ls. There it is. So I want to change my directory to C++ tutorial. No problem. Make sure I spell it right. And ls. And then what we can do, we can just press up on your number pads. You want to go through all these different things. And I can go in here and compile this. There we are. And then I can go and compile this. And there you can see, hello world, you entered 4 arguments. A out prints, that's the very first one. That's the reason why we checked if there was not equal to 1, because this comes out by default if nothing is passed in. And then you can see we cycled through every single string that was then passed into our array and printed all of that stuff out. Now over inside of Windows, we're going to use the command line instead. That's this guy right here. And I believe I am in the correct directory. I can go dir to see what's going on here. No, I'm not. Let's go and change to cpp tutorial and then go directory. And you can see all the different files that we have here. And we're going to type the same thing. If we want to clear the screen, just go cls. And we're going to do the same exact thing. We're going to go g++ main.cpp, and that's going to go and compile our program for us. We can go dir, and we can see a list of all of our applications we have here. Then what I can do is go a.exe, and I love C++. And whenever I do that, it goes, hello world, you entered 4 arguments. It prints out the application, and I love C++. Okay? So there is all of the differences between Mac OS running C++ applications. That's how to get arguments into our program, which we're probably never going to do ever again, but I just wanted to cover it just so you knew how that worked out. And now I'm going to jump over into our second example. Okay, for this example, I'm going to talk a lot about data types. So I'm going to go and get another preprocessor directive, and this one is going to be called limits, and it is going to be used basically to find the minimum and maximum values for a whole bunch of different data types. And I'm also, what I want to do here, basically whenever we create a variable, what we are doing is telling the computer how much memory to set aside for the value and what name we want to associate with that data that we're going to be storing. And variable names are going to contain letters, numbers, underscores, but no math operators, spaces, and the very first value in your variable name cannot be a number. If you would want to define what is called a global variable, which is going to be a value that is accessible everywhere in your program, you're going to just, outside of your main function or any of your functions, you're just, in this situation, I'm going to create an integer, and I'm going to put a G in front of it. This is referred to as Hungarian notation. You can either use it or you can't. And if you do, you're going to either put an I or an N representing that this is an integer. Don't worry about all this stuff. I'm just going to put random number is equal to 0, and just know that that value right there can be accessed anywhere. Another thing that's sometimes very useful is to use constant values. And this just means that once you assign a value, you're not going to be able to change it. And this is going to be a double, which means that it has decimal places. And I'm going to put pi inside of here. And we can do something like 3.14159, blah, 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 blah. And there you go. And that is going to be how we define constants. Now, the different data types that are going to be available to us are going to be booleans, which are either going to have a value of true or a value of 1. 1 and true are the same thing, or false or 0. And to define them, you just go bool, and I'm going to use Hungarian notation here again, and I can say something like married is equal to true. Okay, so there is a boolean. We also have character types, which are going to store one of 256 possible characters. And these are basically going to be the characters that you see on your keyboard. And to define it, we can go ch and my grade, and then surround whatever character you want inside of there with single quotes. And there you go. Now you have a character. You're also going to be able to have unsigned integers. And the reason why we are potentially maybe going to use an unsigned integer is we know that we are never going to need a negative value. So what that's going to allow us to do is to, well, let's work our way up here slowly. So we'll go short. I'm going to show you here in a second how to find out the minimum and maximum values for all of these. So I'm creating an unsigned short integer. This actually has a maximum value of 65,535. And what do you think the minimum value is? It's unsigned short integer, 0. So if we would want to come in here and define one of those, we could do something like U16 and age is equal to 43. And we could go short integer. They have a maximum value of 32,767. So this is a short int. The reason why is it has a minimum value of negative 32,000 and such. So we're going to go something like weight is equal to 180. And I also have regular old integers. And I can go end days is equal to 7. We can also have long integers, and spell long correct. Long, and these are gonna be very large numbers. So I can go, as long as it doesn't have any decimal places in there, and I want a big number, that's a very good option for us. We also have floats, and we could do pi once again or something like that. And you can use, what I'm using here is camel case for my variable name. So you can see each time I have a new word inside of my variable name, I'm using uppercase letters. And I can go something like 3.14, that. And then we have, after that, we have doubles. And I can do something like db and big float is equal to 1 point. And I'm actually going to put 20 ones inside of here. And I'm going to use this as an example here in a second to show you the different precision that these different data types provide. And then also we have long doubles. And those are even bigger doubles. So there we go. Whoops, 1.4. I know somebody in the comment section is going to get on me if I don't type that in there. Okay, so those can be even bigger. Another thing you can have is you can actually have the compiler go and assign your type for you. And if you do that, you just type in auto. And I'll say something like, what will I be is equal to true. And it's going to see true as the value. And of course, it's going to turn that into a Boolean automatically without you doing anything. Now, if I want to see how big these different values can be, I can go standard cout. And then I could do something like minimum bool. You already know what that is, but I'm going to show you how to get all of them. And then to get the maximum, I can go standard and numeric limits. And I can also, like I said before, come down here to the next line if it would be a little bit easier for us to work with. And numeric limits. And then inside of it, I'm going to put the data type that I want to look at. So I'm going to go bool, and then I'm going to follow that up with min if I want to get the minimum value for our Boolean. There we are. And then I'm going to do something very, very similar for getting the maximum. So let's just change this to maximum bool, and then we'll change this to max. And then we can go and save that and run it. And you're going to see the minimum Boolean value is 0 and the maximum Boolean value is 1. And so you didn't have to watch me type all that out. I went and did that for every single data type we have here. So I'm going to save this and run it. And you can see right here, the minimum value for a short int, 0, And there are short ints, and there's an int, there's a long. You can see how big the longs get. There's floats, and there is long doubles. Okay, so those are all of the minimum and maximum values for most of the major data types that you will ever use. Another thing that's interesting is you can get the number of bytes used by a type. So let's go in here and I'll show you how to do that. And don't try to memorize this stuff. That's why I provide a cheat sheet. So I'm going to go int and size. And to get that, you can just go size of, and then you could throw int inside of there. And if we execute that, you're going to see that we have 4 bytes in an integer. Another thing that's important to know is that these different data types lose precision during calculations, and that's very important if you're trying to do very precise calculations. So what I want to do here first is demonstrate how a float could lose precision. So let's go and get rid of this. Well, let's keep this guy and let's get rid of these guys. Okay, let's demonstrate how floats either get or lose precision. So I'm going to change this guy's name to big float, and then I'm going to change this to 1, and then put 10 ones after it. And I'm going to copy that, and I'm going to create another one. I'm going to call this big float 2, and it's also going to have 10 decimal places after it. And then I can create another one, and I'm going to call this float sum is going to be equal to. And to add values, just use addition, just like you would think, the addition operator. So I'm going to go big float plus big float 2. And then what we're going to do is we're going to see how much precision is lost. Now we can still use the C printf function for formatted printing if we'd like. And we could do something like f float sum precision. And then if we want to come in and show 10 decimal places, what we're going to do is put a % and a period and then 10. That means we want to see 10 decimal places on our screen. And this is a float, so we're going to put an F inside of there and then a new line. And then we're going to refer to the data that we want to be shown right here whenever our program executes. So we're going to go F float and sum and like that. And then we can execute it. And you can see right here where we lose precision with floats. So 1, 2, 3, 4, 5, 6. So we have 6 places of precision with using our floating point numbers. Okay, so that's a good thing to remember. Now, without changing anything here too dramatically, what I'm going to do is I'm going to instead change this into a double, and then you're going to see, so I'm going to double this up to 20 decimal places, and we can go and call this db big float, and paste that in there, and then db big float 2, and then change this to a double, and then change this to a double, and then we're going to change these. This is going to be db big float sum. Well, let's get rid of that altogether. So let's just call it db float sum. So let's get rid of the big part. And then we'll just throw this in here and throw this right here, and then change this to a double. And then whenever we output this, we actually can still have that be an F. But in this situation, let's say we want to have 20 points of precision and throw that there, get rid of this, and there we go. And change this also, and then get rid of this guy. Okay, so we can save it, execute it, and there you can see is our precision. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points of precision using a double versus the 6 that we have with a float. Okay, so that's the major difference that we have, aside from the mere size difference between floats and doubles. And I just thought that was something interesting to think about. Another thing is there's a whole bunch of other different things we can do with printf. So we can go printf, and let's say that we wanted to show a character. We can have a character, and then we can have an integer with a %d, and then we can say that we want to reserve 5 spaces in our output that's going to be justified right with a decimal. So that's 5d. And then let's say that we want to have 3 decimal places for a float that we're planning on printing out, and that we want to print out a string. So those are all of the codes that we're going to be able to use for using all the different common data types that you're going to use. So then what you're going to do is inside of single quotes, you're going to put a character, and then you can have a decimal, and I'm going to put a 5 inside of there. Remember, that's going to be right justified. If you put a negative sign, it'll be left justified whenever it prints out. 3.1234, that's going to convert that to only 3 spaces, and then high is going to be the string that we want to output, and have that set up. And there you can see is the right justification. You can see there's a 10, and this has been cut down to 3 decimal places even though we had 4, and there is our string printed out. So those are just a couple examples of different ways we can use printf and different data type sizes and so forth and so on. And now I want to show you how we can work with both math operators as well as receiving input from the user. Okay, so let's come in here, and very first thing I want to do is I want to show you how to create a string. So we're going to be able to go standard and string, and let's say that this is going to be a string that we want to store, that we want to output on our screen. So we can say something like enter number 1. What we're going to do here is we're going to receive data from the user, and then we are going to show different math operations on two different numbers. I'd also like to create some empty strings that I can store some values in. So I'm going to go standard again, and this is string. You can go and initialize multiple different strings all in one line, and we can go to like this. And we could also come in here and give them a value if we'd like, and we can do that for both of them, but whatever. And so what I want to do is, if I want to output information onto our screen, we're going to go cout, and I'm going to go s question, and that is going to give us that information. I do not want a new line in that situation. If I then want to receive user input and store it, I can go getline, and this is going to be a reference to our keyboard. That's what standard cin, that's user input. And then what I want to define is where I want to store it. So I'm going to say s number 1 is where I want to store that in a string. Then what I'm going to be able to do is I can also output, of course, standard cout, and I can have them enter another number, number 2, like that. And then I can go getline once again, and again I'm going to say standard input, and then where I want to store it is in the second number string that I set aside. Now, to actually perform calculations on these, I need to convert from regular old strings of characters into integers I want to use, and I use a function called std to do so. So I'm going to go and define some integers. num1 is equal to standard stoi, so string to integer, and then I just pass in the string that I want to convert, and it stores it for me. And then I can grab this guy right here and change this to 2 and change this to 2. Okay, so we converted our strings into integers. Now what I want to do is print out, perform a whole bunch of math calculations and print out our results on the screen. So what I'm going to say is I want to get the integer that they passed in plus the second integer they passed in is equal to, and then this is going to be the result of our math calculation. So to have those go into place, once again, I'm going to go n num1 and n num2, and then perform my calculation. I can either do it outside or directly inside of our printf function. And then once again, any place that you have the commas, you can go and separate those so it looks a little bit neater. Maybe it looks neater, I don't know. And there we go. So there we go. So that's how we can perform addition. So very useful skill to have. And then we can also go and perform some subtraction on these. And we just need to change this to subtraction. And then we can do multiplication. I'm going to get a lot more into all the different math functions we have as the tutorial series continues. And if you have anything specifically you want me to cover, definitely leave that in a comment. And then we have modulus also, which is going to give us the remainder of a division. And because we use these to represent different values, that we want to put in here, the percent signs, if we're using printf and we want to actually use a percent sign, just put 2 of them inside of there, and then it works perfectly fine. And percent sign, and we can save it and run it. Oh, and it gave me a little bit of an error. Let's go and put that extra colon inside of there. And it says enter a number. I can put 5 inside of here, and I can put 2 inside of here. And you can see it performs all of the different calculations as you would expect them to do. Once again, modulus gives you the remainder of a division. So 2 goes into 5 2 times. What's left over? 1. And there you go. You can see your result. All right, so now what I want you to do is we're going to come to our first problem of many. I've provided you everything you need to know to be able to solve this problem. What I want you to do is to receive user input, and I want you to convert miles to kilometers. So basically all you need to know is that a kilometer is going to be equal to whatever miles are multiplied times 1.60934. So that's a bit of information you're going to need. You're also going to need an example of what I want your program to look like. So your program is going to say enter miles, for example. The user is going to enter 5 as an example. And then you are going to enter out 5 miles equals 8.0467. I only want you to show 4 decimal places and then kilometers. Okay? So that is going to be the program. You can pause it and try it out yourself. I'm positive that you can do it. And otherwise, I'm going to show you how to do it right now. Okay, so what we need to do first is we need to create the variables we're going to need. So we are going to go and create a string, and this is going to contain miles. That's going to be the data we get from our user. We're going to have to use doubles now instead of using integers. So d miles and d kilometers. All right. We are then going to have to ask the user for input like we have right there. So I'm going to go cout, and then I'm going to say enter miles with a colon, and then I'm going to close that off with a semicolon, of course. I'm then going to get the data from said user. So standard, cin, and then I'm going to store the value they pass in into my miles variable that I created, which is a string, and we know that because there's a little s right there. I then want to convert my string into a double, so I'm going to go d miles. So we went and converted our string into a double, and to do so, you're going to use a function called stod. So there's that. Okay, so there's d kilometers. That's what I called it up here, right? Yes, d kilometers is equal to, and I'm going to go d miles times 1.60934. And then what I need to do is output our results. Now you could have either used printf or cout, depends on whatever you felt like using. And I'm going to say %.1f miles equals, and then I'm going to go %.4f kilometers. And then throw in a new line. And then after that, we're going to go d miles and d kilometers. All right. And if I typed in everything right and run it, enter the number of miles, and I said that I used 5 as my example, and whenever I ran it, I got 5.0 miles equals 8.0467 kilometers. Okay. So hopefully you guys got that. If you didn't get it, that's okay, especially because of my little error inside of there. And I hope you guys enjoyed this tutorial, and like always, please leave your questions and comments below. Otherwise, till next time.